My name is Ricardo Gonzalez. I'm a senior principal product manager for the high availability, scalability, and maximum availability architecture PM team at Oracle. And today I'm going to be talking about how to efficiently migrate your Oracle databases on premises to the Oracle Cloud. As a product manager, I oversee the CFS cluster file system, overall cloud database migration, and the ZDM or zero downtime migration product. Today, we're going to be talking about the product itself that powers the migration to the Oracle Cloud, which is ZDM or zero downtime migration. I'll be giving an introduction and a general overview of the product, talking about its architecture, how it's work, how it's actually deployed, all the different features and functionalities. Then I'm going to be going a bit deeper and talk about the different methodologies and workflows of the product. So it has two ways of working. ZDM can migrate databases in a physical workflow in different flavors. So we can do offline migration, online migration, with a backup location or direct data transfer, and also logical migration. The logical migration can also be offline and can also be online, including the use of other products and tools. So I'll be talking about all of that and how it works and how it can help you automate and make your journey to the cloud, simpler and easier. Finally, I'm going to be summarizing the presentation and sharing with you some resources that we have for you regarding the product and overall cloud migration. So ZDM as a product has been in development for a long time, and it was finally released in 2019. Zero downtime migration, or ZDM, was born with the idea to automate your migration process so that moving database workloads from on-premises to the Oracle Cloud would be simple. Now, we understand, of course, that a migration to the cloud has many steps. There's many prerequisites, many things to be taken into consideration. So when you're migrating with ZDM, what we do is we help you to understand what are the requirements, what's needed, connectivity, backup, etc., so that once everything is in place, ZDM will work as simple as possible by having automating all the process for you, right? I'll be talking about how that works in a bit. We're also fully MA compliant, meaning we follow the maximum availability architecture best practices. And so that's actually great. And of course, we provide a highly available way for migrating your databases to Oracle Cloud in a safe way, secure way with no data loss. And really, really important, one thing that we've been working for is to make it free so that the product itself has no cost. It's a fully licensed product, and the product follows under an Oracle license. It has support, and when you use it, there's no cost for you, regardless of the migration method, either if it's physical using other tools or logical using other tools. And I'll be talking about that just as well in a bit. Now, how does ZDM work? I'll be talking about the architecture in the next slide, one for the physical migration, and the other one for the logical migration. But let's start with the basics, right? You have a service node, which we call the ZDM service node, which could be running on a VM anywhere. It could be on the source database server. It could be on the target database server. It could be in OCI compute. It could be on your premises. The importance is that that VM is running on Oracle Linux 7. Now, you download ZDM. It's quite a simple binary. It's 800 megabytes. You install it on that ZDM service node. Once it's deployed and configured, there's a response file. And that response file has information that you have to fill with source database information, target database information, connectivity, migration methodology, etc. Then ZDM has a command line interface, ZDM CLI. So you issue a command under that command line interface called migrate database, pointing to the specific response file and some other authentication parameters. And then ZDM will do under the covers all the work for you. Now, I'll be talking about the process, of course, in a bit, and the overall architecture as well. Now, as I mentioned, we're fully MA compliant. The product, has a lot of features and functionalities. So we grow to the size of your fleet, can tackle different types of databases. You can pause and resume the migration at any given time. So, for instance, you could say, well, I want to migrate my database, but when it arrives a certain point before I do any switchover, I want to actually pause the migration, do some testing, and then continue. That's completely doable. You can do it before starting and telling ZDM which phase you want to pause the migration in, perform all your testing, and then continue. Also, really important, we have a drive run option. So basically, this means that we can perform a migration without actually migrating your database. What that means is that you will be doing an evaluation mode. Basically, ZDM will do and mimic what would happen during the migration, and then tell you, okay, everything went perfectly, there's no problem whatsoever. Or actually, during this phase or this other phase, you need to actually correct some action before you go with a real migration. So you do that then, right? We also have the possibility of customizing the workflow in different ways. Really important is that the encryption at target level is automated. And what do I mean by that? As you know, all Oracle Cloud Infrastructure databases are encrypted by default, so they're TD enabled or transparent data encryption enabled. But some, databases on premises might not have TDE, might not be encrypted, right? So that's okay. We take care of that, and if you have an unencrypted source database, we will take care of the encryption at target levels. So you don't have to worry about that. As I mentioned, we grow to the size of your fleet, so we can migrate single instance databases, RAG databases, RAG one node databases, etc. But also we can do them all in parallel. So when you issue a migration command, ZDM will generate the job ID, and then you can start querying that job ID to see how it's going. But ZDM will be working on the background. So you can actually have a second response file for a second database and issue a migration command as well for that one, and so on and so forth. So you can migrate multiple databases in parallel and then have to wait for them to finish so that ZDM can migrate them. Also, we have the possibility to schedule operations. So you could say, well, I actually want to migrate my database at 3 in the morning on Saturday when the workloads are lower, there's less risk. And then I come Saturday morning and check how's everything going, or even if the process is already finished, then I'm good to go. Now, talking about architecture, I'm going to talk about physical migration and then logical migration. And further in the presentation, I'll be explaining how the different workflows work. But for now, what I'm going to do is explain at least what are the components required for each one. They're quite similar, actually. So basically, you don't have to worry. I think they're the same, but logical migration does have an extra pair of components. So in the case of physical migration, you have the ZDM service node. It's really important, as I mentioned. Any VM, any box that is running on Oracle Linux 7, we don't require a lot of compute or memory, etc. Just enough storage. And by enough, I don't mean a lot, actually. Just 100 gigabytes storage, because we generate a lot of logs during the migration. So you want to have the space so that you can then go and do a proper auditing on what happened during your migration. And we have the source database that for physical migration, we support Oracle databases on premises, even in OCI as well. And these databases have to be 11.204 and higher. Now, really important, these source databases must be on Linux platforms. These for physical migration. Then we have the target database cloud service. Physical migration can migrate to Exadata on premises, actually. So beyond cloud migration, it can migrate to database cloud service, both bare metal and virtual machines. It can migrate to Exadata cloud service and Exadata cloud customer as well. Now, we use a backup location to migrate with the physical migration. So when you're migrating to an OCI native database, you would be using the object store. But if you're migrating, let's say, to Exadata on premises or Exadata cloud customer, then that backup location would be NFS or the recovery appliance. And of course, we require connectivity between all the different components. Now, for the logical migration, it all stays the same, right? Except we have some differences here. First of all, the sources databases can change. We also support databases running on AIX platforms or Solaris platforms. Of course, they have to be Oracle 11.204 onwards. And we also support Oracle databases running on AWS RDS. For target platforms, we support Database Cloud Services, Exadata Cloud Service, Exadata Cloud Customer, and the Autonomous Database, both in transaction processing and data warehouse. Now, for backup location, is exactly the same, but we have the added feature that we support database links. You can actually do a direct database migration with logical migration using database links. We normally only recommend it, of course, for smaller databases, so 100 gigabytes or less. And finally, we use Golden Gate. So we have a Golden Gate hub that is deployed on OCI compute node, and it uses a specific image. This image for Golden Gate comes from the OCI Cloud Marketplace. So this image specifically is called Oracle Golden Gate for database migrations, and it's was created with the specific purpose of being used for ZDM and the database migration service, which is a service native to OCI that is powered and has as an engine ZDM. Now, this image that we have has a specific licensing usage for 180 days for the time being for migrating databases for between on-premises and the Oracle Cloud when you're using it with ZDM and DMS, which is great because that means, as I mentioned before, ZDM will help you bring your database to the cloud, and it's free. Even when you're using Golden Gate, specifically with this Golden Gate Hub, using the microservices from the specific image from the OCI marketplace. Now, the last release for ZDM was 21.2. We released this release in August 2021, so it's quite new. 21.2 has a lot of new features and functionalities. So what I'm going to do right now is going to talk about how this works overall, like what are ZDM features and functionality, and then talk about the new features, right? So for service databases, as I mentioned, we have 11.204 onwards. We can migrate standard edition databases and enterprise edition databases. Also databases running, Oracle databases running on AWS RDS, and platform-wise, Linux databases. So databases that are based on Linux platforms for physical and logical migration, and then AIX and Solaris for logical migration only, right? Now, target-wise, right, as I mentioned, Database Cloud Service, Exadata Cloud Service, Exadata Cloud Customer, Exadata on-premises, and the Autonomous Database. Now, we support non-CDB to CDB conversion for both workflows. This is important to mention that when you're doing it with logical migration, it's straightforward. When you're doing it with physical migration, there'll be downtime because, of course, after the migration, we'll have to do the plug and plug operation. We support, again, physical and logical migration, and I'll be explaining how each workflow works in a bit. And we also support in-flight upgrades. So you can actually migrate from an 11.204 database directly to a 19.6 database. Now, this, of course, is limited to logical migration only. When you're performing a physical migration, it has to be from the same version to the same version. And then we use different technologies. For physical migration, we have RMAN backup and restore for physical offline migration, and we have the use of RMAN backups and DataGuard for physical online migration. And then for logical migration, we have DataPump for an export-import way of migrating your database on an offline fashion, and then we use DataPump in combination with Golden Gate for a logical online migration. Now, regarding the new features in 21.2, we introduced the option of migrating Oracle databases residing on AWS RDS to the Autonomous Database with logical offline migration, the support for AIX and Solaris-based Oracle databases for logical offline migration as well, physical direct data transfer. So basically it means that for physical migration, we have the option, customers can choose whether to use or not the object storage or a backup location to transfer the backup files. There's also a way to do it directly between source database and target database, and I'll be talking more about that in a bit. Then, of course, we have the option to use existing RMAN backups. Because normally ZDM, what it would do is it would create L0 and L1 RMAN backups and then transfer them to a backup location. And again, I'll explain more about the actual workflow in a bit. And then use those backups to instantiate a target, right? Now, if you already have existing RMAN backups, now you can actually tell the ZDM where they are and then reuse them rather than actually going through the whole process of creating them. Then we have several migration enhancements that I'll be talking about in a bit. And we have a pre-migration advisor for logical migrations to the Autonomous Database that has now been updated with no new features and functionality as well. So new in 21.2, logical offline migration from Oracle databases on AWS RDS. This uses the logical offline migration where we do an export from DataPump, then an import on the target. For the transfer of the data, you can either use database links or S3 buckets. For AX and Solaris-based Oracle databases, now we also offer the support. Before, ZDM only supported Linux-based databases. Again, you use the logical offline migration method, use a backup location or database link if you wanted to, and you have a bigger array of targets like Database Cloud Service, Exadata Cloud Service, Cloud Customer, and of course, the Autonomous Database. As I mentioned, for physical migration, and for all migrations, actually, we use a backup location, but now with 21.2, we have the possibility to do a direct data transfer. So basically, you're avoiding the need to actually, create the backups with an intermediate store, like, again, NFS, recovery appliance, the object store, and hence you have a faster migration experience because it's direct between primary and target. For 11.2 databases, we use active database application, and for 12 and higher versions, so 12.1, 12.2, 18.19, we use a restore from service. Now, as I mentioned, we create backups from scratch, then transfer them to a backup location. But if you have existing ones, you can tell ZDM and it will actually you reuse them so you have a faster migration, but because you don't have to wait for ZDM to create the backup for you. And then migration enhancement wise, well, for logical migration, we use data pump. So for estimating the dump size, we now use the statistics method as well. It's actually available, so you can choose either or. For logical migration as well, we do an automatic creation or remapping of the table spaces from the source to the target. If you have provided any action scripts that you want ZDM to do, at any phase or any given time, they can now be modified on local level. And of course, for the response file that ZDM uses, in logical migration, you can now change some of the parameters if you need to while the migration is taking place. And so there's certain restrictions for this, but at least now you can do some in-flight modifications if you're required to do that. Now, as I mentioned, we have a pre-migration advisor that helps with logical migrations to the autonomous database. So now it can be now updated directly from the ZDM home. And also if it provides any scripts that are, for you to perform, you can now run them and automate them directly as well. Now, let's talk about different methodologies, how ZDM works. And I'm going to start first with physical migration and then go to logical migration, right? So physical migration, as I mentioned, has to be same version to same version. So you have 11G to 11G, 12C to 12C, and so on and so forth. But we do have the possibility to have a higher patch level on the target. So if you are migrating from 11 to 11, but the patch level on the target side is higher, that's fine. What we would do is we would automate the run of data patch at the end of the migration, so you don't have to worry about that. We also offer non-CDB to CDB conversion. So ZDM will perform either an offline or online migration. And once the database it's at target level and we have performed the switchover, we would actually do a plug and plug operation so that you now have a CDB at the target level as well. For target platforms with physical migration, Database Cloud Service in the flavors, Exadata Cloud Service, Exadata Cloud Customer, and Exadata on premises. So if you're doing hardware refresh projects with Exadata, you're moving to newer Exadatas, then ZDM is a great way to move your existing workloads, those new Exadatas. We have two ways of working, either physical offline migration, which is a supported method for a standard edition databases, because what we do is we do an RMAN backup and restore methodology in which we transfer the backups to a backup location, then instantiate a target database and perform the switchover for you. But also enterprise editions can be supported with that, right? And then we have the physical online migration, which basically what it does is it uses, again, the same methodology of transferring RMAN backups to a backup location or doing a physical direct data transfer. But then we instantiate a standby on the target. We sync them up, so primary and target and standby database in the cloud. And once synchronization is over and we're ready, ZDM will take care of the switchover on the role swap. So you end up with a primary database on the cloud. So what I'm going to do now is actually go and talk about a little bit about the step-by-step of the different ways of migrating, but specifically, I'm actually going to go and talk about physical online migration with a backup location. So let's get on it. The first step, of course, is to download ZDM and configure it from the product website, which is www.oracle.com/go-to/ZDM. You download ZDM, install it on that box, as I mentioned, the ZDM service node that could be a VM running in CI Compute. It could be running on the source database server. It could be running on the target database server, as long as it's a separate box with Oracle Linux 7. We don't want it to be running in the same place where you have a grid infrastructure home deployed. So that's the only requirement we have. You will then configure it, be sure that everything is in place, that connectivity works and everything is fine between source, target, backup location, etc. And then pre-fill a response file, as I mentioned, with the following information: migration methodology, physical online, backup location information, source database information, target database information, and any fine-tuning that you might want to do, because there's possibility of doing certain parameters of configuration at the response file level. Then you issue the ZDM CLI, or the command line interface that we offer, migrate database command, with pointing to the specific response file and with certain authentication information. So once you do that, and ZDM will ask you then for passwords, etc., then we will continue and perform the actual migration. When we start the workflow, what it does is that first ZDM will connect to the source and the target, be sure that everything is in place, database versions match, everything is, we can reach all the different components, and if everything is in place, then we will continue. What we continue to do is then connect to the actual backup location. So right now, let's assume we're migrating to an OCI-based database. It could be Exadata Cloud Services. So great, we're migrating to Exadata Cloud Services. We're connecting to the backup location, which in this case is the object store. And then Once that happens, we start transferring or creating and transferring the RMM backups from the source to that backup location. So we start doing that because we will be using those backup files. How are we going to be using them? Well, once the transfer happens, we actually instantiate a standby database on the target. So now we have an XSCS running with a standby database in OCI, which is great. Now, this database, of course, is out of sync because it's created out of backups. However, the source database has still, the primary has still been active. The application still has workloads there. So, of course, there is a discrepancy. What we need to do now is sync them up. So ZDM will instruct the primary database to actually set up SQL Net connectivity to the actual target. So now we have a primary and a standby configuration, right? And SQL Net connectivity between the primary and the target database in the cloud and XSCS. And what here ZDM will take care of to be sure that when the synchronization happens. Now, really important, as I mentioned, let's say your primary database is not encrypted. It doesn't have TDE by default. That's fine. We'll encrypt the target. The next step is when ZDM does something interesting. Once it's ready, it will actually perform a switch over and a role swap. So now you have a primary database in the cloud and a standby database on premises. You could actually potentially pause in the previous step or pause here, actually at any given time. But let's say we pause here right now. So ZDM will pause the migration. The synchronization will still be ongoing, so you have a SQL net there, but you have the standby database on premises not encrypted, but the primary encrypted, right? So it's really important that when you're planning this, you know that the migration will take place and you'll have a primary that is encrypted and a standby that might not be. And if that's the case, you need to take certain things in consideration. If you ever want, for instance, do a hybrid DR solution, which you have a standby database in premises and the primary in the cloud, or the other way around. So this is really important that you take that in consideration, and then when you're ready, you just continue and move forward. So you issue the command to continue, or in the case if you didn't pause, ZDM will just continue, be sure that everything is in place, and finalize the migration by doing pre-checks and post-checks. So being sure that before the migration starts, we pre-checked everything, and then when the migration is done, we check that the source target, everything is in place. Now we have the application pointing to the primary database that is now in the cloud. We're good to go. We clean up all the environments and we finalize the migration process. So that's kind of like how physical online migration works. Now, what about logical migration? Well, let's talk about that. Logical migration, which was introduced in ZDM 21C, has the possibility to migrate between different versions. So you can actually migrate from 11 to 19, 12 to 19, etc. And also, of course, has a direct way of doing non-CDB to CDB migration, which is perfect. Now, we have pretty much the same targets, except we don't have Exadata on premises. But now we have autonomous database, both in transaction processing and data warehouse, and also in shared and dedicated mode, which is great. Now, how does it work, right? We have different ways of actually migrating your database with logical migration. One is the logical offline migration. Basically, we do an export import data pump to a backup location or directly with database links. And then we import the database, the target level, and then we do the switch over, right? And both supports both standard edition and enterprise edition databases. Now, we also have the logical online migration, which does data pump and Golden Gate databases. Data pump and Golden Gate for the migration. And we use either backup location or database links. And this targets all the different services, as I mentioned before. I'm going to now talk more about the logical online migration and how it actually works, so you can see the overall architecture and how it can actually benefit you. Route. So first, let's look at the architecture, right? So we have here the application connected to your on-premise database, ZDM connected both to the source and the target, a backup location in the middle. So it could be, again, if you're migrating, let's say, to the autonomous database, in this case, the backup location will be the object store. Then you have a Golden Gate Hub that is running in an OCI compute node with two microservices, an extract that is capturing transactions from the source database, and a replicate that is feeding out of the trail file generated by the extract and synchronizing the database, the target database, which is the autonomous database, of course. So I'm going to run you through all of this, but before actually I want to talk about how this Golden Gate Hub works, right? As I mentioned, there's a specific image that for the Golden Gate Hub, it's called Oracle Golden Gate database for database migrations, has specific licensing, so you have 180 days of usage for it, as long as you're migrating your database to the Oracle Cloud with ZDM or the database migration service, which is great. So we're offering that for you, which makes me really happy. And I know it's going to be really helpful to make your migration to the cloud, as successful as possible. Now, how do we start? First, the same thing. We download and configure ZDM. We will have same product website. I'll repeat it so you can come and visit and get all the information. www.oracle.com/go/ZDM. You download the binaries in a box. Again, Oracle Linux 7 running on a VM, could be deployed pretty much anywhere. Configure it. You're good to go. Pre-fill a response file. In this case, you're saying methodology, logical online migration, target, Oracle Autonomous Database, target information, source information, backup application, etc. And then you issue the ZDM CLI migrate database command pointing to the specific response file. Now, ZDM will start by connecting to the source database and the target database. In this case, let's say it's an autonomous database. Do all the pre-checks, be sure that we're fine, all the different users, requirements, etc., and we're good to go. Then, what we do is we're gonna connect to the backup location, and ZDM will be sure that everything is perfect and we're good. We have enough space, etc., and we'll continue the migration. So the first step is to deploy an Oracle Golden Gate extract microservice, and that is extract microservice will be configured by ZDM, and we'll start actually capturing transactions from the source database and start generating trail files. Then what we're going to do is move on and do a data pump export job over the network between the on-premises database and the backup location. And this is really important because then that information is going to be used for the next step, which is what? ZDM will then do a data pump import job on the target, get that info, those data pump dump files that were on the backup location, and instantiate the target database, in this case, the autonomous database. But let me stop for a second there. If the target is the autonomous database, the ZDM instruction to do that instantiation, getting the data pump dump files, is completely done by ZDM, and the autonomous database will understand and do it directly. But if the target, let's say it's a customer or Database Cloud Service, virtual machines, bare metal, or Exadata Cloud Service, what ZDM does is that ZDM copies those or transfer those files from the backup location to a local file system on the target, and then that the Database Cloud Service that is the target will do the import and then the target instantiation. Of course, all of these automated. They're just that different, right? That one is directly from the backup location from the autonomous database. The other one, ZDM will do the actual transfer of the files first, and then perform the actual database instantiation with the import job with data pump. So now we have two databases, right? We have the source database and the target database in the cloud, but of course they're out of sync. So ZDM then will configure an Oracle Golden Gate duplicate microservice, again from the same image, that will be fitting out of the trail file generated by the extract, all running on the OCI compute node that we call the Golden Gate hub or the DG hub, right? So now we have the on-premises database, the target autonomous database, both being completely synchronized by Golden Gate. You could actually pause here, and if you want, perform any like transactions on the source level, and it will be replicated on the target level, right? We don't support DDL on the fly, but we'll support data modification. So if you're going to do any inserts, deletes, etc., we'll take care of that without a problem. Now, once we're good to go, ZDM sees that the source database is ready. It will then proceed as switch over, and now the application will be pointing to the target database in the cloud. And when everything is good to go, we have performed all the pulse checks, be sure that the migration is completely fine. What we do then is we proceed to actually finalize the migration, clean up all the different environments, and finalize completely with you having now your database in the Oracle Cloud fully migrated. Now, as I've been talking with you, ZDM is a great solution. It powers other products in Oracle, like the Database Migration Service, has different sources, different targets. It offers the best-in-class way for moving your database to Oracle Cloud, different workflows, physical, logical, using different products, Golden Gate, DataGuard, Arma, and Data Pump, always constant flux of releases and with new features and functionality. And really important, it's cost effective because it's free and helps you migrate your database at no cost. Now, I really appreciate your time with me today. I'm really glad that you were able to join me. So thank you so much for everything. I want to share and leave you with the actual resources, our website, oracle.com/go/ZDM. You have step-by-step guides, different information there for you. So please come and take a look for that. Thank you so much for being here with me today.